Hello friends, myself Dr. Ritu. I am again with you to proceed one more step towards C++. Last time we have discussed about basic elements of C++. We have learned about variables, constants and basic data types. We have also tried our hands on writing small program, simple sequential programs. But my dear friends, actually programming is much more complex than this. Sometimes we have number of alternative solutions of a problem. In such cases, we have to choose a right solution depending on our situation. For example, suppose you are walking on a road. Suddenly, two different paths are available in front of you. Both these paths reach to the different destinations. Which path will you choose? What are the reasons for choosing a particular path? It all depends on your destination. In other words, what is your goal? What results do you want? You have to take decision to fulfill your goals. In C++, such type of decisions can be taken with the help of selection control statements. Now, let us view the solution for the same problem from different angle. You will go on walking till you complete 5 kilometers. Such cases can also be handled in C++ using iterative control statements. Technically, we can say that a programmer has to take a decision in order to achieve a right solution. In such cases, different pieces of program are written corresponding to the different conditions. During compilation of the program, the control of the program passes between different program pieces depending on the condition. The program piece which has a control is active, making other program pieces inactive. This is known as a flow of control. Control statements provide a way to a programmer to control which piece of the program is to be executed. These are implemented using one entry, one exit concept, a popular approach used for structured programming. Normally, the statements are executed sequentially from top to bottom in the program. This is known as normal flow of control statements or sequential control statements. Other types of control statements like selection control, iterative control and transfer control statements. Transfer the flow of control either conditionally or unconditionally to some other block of statements, that is program pieces. The conditions can be written with the help of relational operator or logical operator for simple conditions or with the help of relational operator and logical operator for compound conditions. Selection control statements are classified as if statements or ternary or conditional operator or switch statement. If statements can be further classified as if simple, if block or nested if statements. Iterative control statements form a loop structure like for loop, while loop, do while loop. Flow of control of statements can be transferred unconditionally also with the help of go to statements or break or continue statements. Now, let us discuss each of them in detail. Selection control statements. Let us start with selection control statement. These type of statements are used where there is a need to take a decision for selecting a right path to achieve goal. For example, you have to attend your college during rainy season. Under what conditions you will take umbrella? The condition is simple. If it is already raining or it is very cloudy, you will not forget to take umbrella. Similarly, if you are physically fit and good hockey player, then only you can be selected for a hockey team. There can be many more such type of situations where you have to take decisions. Such kind of situations can be very easily interpreted in C++ using selection control statements. In the language of C++, we can say that when the statements are executed depending upon some condition, then they are known as selection statements or conditional statements or decision statements. Conditions can be designed with the help of relational operators or logical operators for simple conditions, or with the help of relational operator and logical operators for compound conditions. Any kind of above said situation can be depicted by a flow chart like this. Flow chart depicts that if the given condition is true, then S1 statements will be executed, else S2 statement will be executed. So, the path selected is executed for once only. The selection control statements can be either if statements or ternary statements or switch statements. Now, let us discuss each type of selection control statements. The very first one is if statements. They are used to execute the program depending on some conditions. They are further classified as simple, block, nested if statements. Simple if statements. Let us play a game of guessing. Suppose I have a number in my mind and you have to guess it. I give you a hint that the number lies between 1 and 10. Now, whether you have guessed me right or wrong depends on the number you have chosen. Now, let us try to write a program for it. After including the header files and declaration of variables, input the number you have chosen. If that number is equal to 5, then you have guessed right number. Otherwise, I cannot say anything, that is, no output will be generated. Technically, we can say simple if statement is used to conditionally execute a code. If condition is true, code is executed, otherwise it will be skipped. The syntax is if condition S1. Thus, the statement S1 will be executed if the condition is true. This can be illustrated with the help of flow chart also. Second type of if statements are block if statements. Let us play the previous game again, but now I will not keep mum for your wrong answer. I will let you know if you are right or wrong. In this program, you again have to guess a number between 1 and 10. I have chosen 5 in my mind, which is initialized as number equal to 5. If your guess is equal to 5, then you are correct, else if you have thought of 4, then your guess is wrong. Such type of problems can be handled with the help of block if statements. Pictorially, we can define block if statements as separate path consisting of block of statement is executed depending on the condition. Thus, first of all, a condition is evaluated. If the condition evaluates to true, then the first block of statement, that is B1, will be executed. Otherwise, the second block of statement, that is else part, B2, will be executed. Syntactically, it can be written as if condition B1 else B2. There can be multiple statements in a block. This can be easily understood by the following example. In this program, after including header files and declaration of variables, you are prompted to enter the choice. If your choice is equal to 5, then you are right and you know what I am thinking. These two statements make a block of statements corresponding to true condition, while the statements that is you are wrong and I used to think you are indecisive, makes a block 2 corresponding to false condition. Next, nested if statements. These are the third type of if statements. A nested if statement has another if statement in its body or in its else body. They are used in complex situations with multiple conditions. For example, if you want to purchase a car, there must be some condition in your mind for purchasing a car, like car should have best speed with minimum oil consumption. Second point could be it should be red color or black color. It should be within your pocket budget, that is minimum price. So, now you can say you have to choose a car based on multiple conditions. Such type of problem can be best depicted by nested if conditions. Depending on the type of multiple conditions, the nested if statements can have following forms. Number 1, where if is nested within the block corresponding to true condition. Its syntax is, now let us view flow chart. Here on the successful execution of condition 1, condition 2 is executed. If condition 2 is true, statement S1 will be executed, otherwise control is transferred to else part where statement S2 is executed. If condition 1 evaluates to false, then statement S3 is executed. Let us write a program corresponding to nested if condition. The program is to find if one has a red colored rose or not. In this program, user is prompted to enter his favorite colored flower. If the favorite flower is rose and the color is red, then you have a red colored flower. Similarly, if your favorite flower is rose and color is yellow, then output is, just notice statements that are executed for such output. Similarly, you can see the statements that are executed when flower is not rose, then condition for color statement is not at all executed and the output for this will be. There are situations where if is nested within a block corresponding to false condition. This can be explained by syntax if condition S1, else if condition S2, else S3. Flow chart. You can see from the flow chart also, on successful testing of condition 1, statement S1 is executed, otherwise control is transferred to else part where condition 2 is tested. If it evaluates to true, then statement S2 is executed, otherwise statement S3 is executed. Now, let us try to correlate such condition in real life problem. For example, we are going to write a program to find month for a given maximum number of days in that month. Here you can see that if maximum days in a month is 28 or 29, then the month is Feb. In else portion of this condition, there is another if condition to check whether maximum number of days in a month are 31 or 30, and accordingly month name is printed. For example, if sample input is 31, then output is month is Jan or March or May or July or August or October or December. Similarly, you can see that if maximum number of days in the month are 28 or 29, then which statement are executed to print that given month is Feb. And if sample input is 30, then which statements are responsible to print that given month is April or June or September or November. There may be cases where there is a nested if conditions on both true and false side of the first test condition. Syntax for such is syntax if condition 1, if condition 2, S1 else S2, else if condition 3, S3 else S4. Note that this square bracket portion is optional. You can note that pictorially also you can see that blocks corresponding to true and false side of condition 1 has test conditions. From the flow chart, you can analyze that on successful execution of condition 1, condition 2 is tested. If condition 2 is true, statement S1 will be executed, otherwise statement S2 is executed. On failure of condition 1, condition 3 is tested. If it is true, then statement S3 is executed, otherwise statement S4 is executed. Let us take same example of your favorite colored flower. Different kind of outputs can be generated depending on the inputs for favorite flower and color of the flower. For each set of input, different set of code, that is program piece, is executed to generate variety of outputs, like if you have inputted rose as your favorite flower and red as your favorite color of the flower, then sample output will be you have a red rose. Similarly, if you have inputted rose as your favorite flower and yellow as your favorite color of the flower, then sample output will be you have a different colored rose. And if you have inputted lily as your favorite flower and red as your color of flower, then sample output will be you have red colored flower. While if you have inputted lily as your favorite flower and white as your color of the flower, then sample output will be you have different colored flower. Next type of if statements are if else if chain. This is the fourth way by which we can have a nested if statements. When the else part of statement contains another if else statement, it forms a construction which is called as if else chain. It is an extremely useful construction for taking multi-way decisions. Its syntax is if condition S1, else if condition 2 S2, else if condition 3 S3, else if, and it goes on and on. Pictorially, you can also see that each condition is evaluated in order, and if any condition is true, then the corresponding statement is executed and the remainder of the chain is terminated. The final else statement is only executed if none of the previous conditions are satisfied. For example, in the above flow chart, if condition 1 is true, then statement S1 is executed, else it checks for condition 2. If condition 2 is true, then statement S2 is executed, otherwise it will check for condition 3. If condition 3 is true, then statement S3 is executed, else it will again check for further conditions, thereby making a chain of if else if. Now, come with me and try a program for that. We are going to write a program to find a day of a week. In this example, you can see that for every else part of test condition, there is again a test condition. Out of all these, only one statement will be executed to produce the result. Thus, you can see how different kinds of if statements can solve your day by day decision making problems. Ternary or conditional operators. So, friends, you have realized that how a complex decision making problems can be solved so easily in C++. But to your surprise, use of simple if statements can be further simplified in C++. This can be done by the use of conditional operator. It is also called as ternary operator. The conditional operator is a unique operator in C++ which connects the three operands. The first operand is always evaluated first. It is usually a conditional expression that uses a relational and or logical operators. The next two operands are any other valid expression which can be single constant, variables or journal expression or a statement. Its syntax is condition question mark S1 colon S2. Thus, we can say conditional expressions are only useful in replacing if else statements. For example, grade equal to salary greater than 10,000 question mark C colon D. This statement is a conditional operator statement and is a single line statement whose equivalent form is if salary greater than 10,000 grade equal to C else grade equal to D. So, make a habit of using conditional operator in place of simple if else statements. It will make your programming easy. Switch statement. We have learned a bit about if conditions. There may be certain situations where we have to choose a particular option from number of alternative options available. For example, each toy in a toy shop has different rate. Whatever toy we will purchase, we will pay accordingly. In C++, a switch statement is a type of control statement which allows a programmer to make a decision from a number of choices. It is a multiple branch selection statement. Its syntax is switch expression case C1. Thus, we have noticed that each switch statement uses 4 keywords. Number 1, switch. The keyword switch identifies the start of the switch statement. The expression in the parenthesis is evaluated and the result of the expression is compared to various alternative values contained within the switch statement. Second, case. Case is used to identify or label individual values that are compared to the value of the switch expression. Any number of case label may be contained with the switch statement. They can be in any order. Third, default. Default is optional and operates like the case else in an if else chain. If the value of the expression does not match with any of the case value, then program execution begins with the statement following the word default. Fourth, break. The break statement signals the end of the particular case and causes execution of switch statement to be terminated. For example, let us write a program to find the day of a week. After insertions of header files and declarations of variable, user is prompted to enter day in a week. Switch statement checks for the appropriate case and prints the output. For example, if user inputs 5 as day in a week, then day is Friday is printed. This is all about various types of selection control statements. Thank you.